I think we can get started now. The others may be joining us a little bit later. So I warmly welcome everyone for the OpenChoreo community call, which is our second call. We had a great turnout in our first call, and it was a really great session. We had some good conversations. We had some good conversation with external contributors as well. So it went off really well. And in our community call too, today also we have a great agenda in line where we will be taking you through some sneak peek of some upcoming features, which is going to be a project release feature, Cilium, Scale to Zero, and external observability modules. And then we will take you through a code walkthrough of the MCP related code. So any external contributors who are interested in contributing to the source code, this might be of very interest, this session to you. And then we will open the stage for any questions from the community so that we can discuss on any interesting points or any interesting technical discussions, any questions you would have about the project and any project updates. So first, I would like to see if we have any external contributors or any external attendees on the call. I see one of our revisiting attendees, Limani. We have Limani. Would you like to give a small introduction about yourself and maybe tell us how you heard about OpenChoreo? Seems like there's not much of a response. It's okay, Liman, if you want to jump in the middle and want to give a short introduction about yourself, we are glad to give you some space. We can get started with the first session that we have in line. So first we will have Vajira who will take us through the project release feature. Over to you, Vajira.
Yeah, thanks, Kavisha. Hello, everyone. I'm Vajira. I'm an OpenChoreo maintainer from WSO2. So let me share my screen. Yeah, hope my screen is visible. Today I will be presenting about the upcoming feature that is project release lifecycle. So yeah, so let's get started. Yeah, so before going into the feature, like I would like to give you a quick introduction on what's available today. So if you take from OpenCore side, today we have projects, components, and resources. So if I kind of give quick introduction into this project is it represents bounded context in domain-driven design terms. It's kind of like containing group of related components that work together in a particular business capability, right? So then we have components. That is most important part. It represents a deployable unit of software that is the fundamental building block of applications in OpenChoreo. So then we have resources that is like we introduced recently, like in the last release. So that represents a managed infrastructure dependency declared by developer. Let's say, for example, a database. Queue, cache, likewise. So the relationship between these things are like this. Like the project is the top level one, and component, it owns the components and resources. The components are depending on the resources. Yeah. So if let's go to the gap, that the actual problem that is going to solve with the project release feature. So right, today we have components and resources. They also have a clean release lifecycle defined for that. So that means like it has immutable releases, and you can promote component across environments. also the resources has the same thing. And what happens is like um, all these life cycles, like components and resources, when you are promoting them, what happens is finally the rendered Kubernetes artifacts are deployed to a cell. We call it cell namespace, and it is that cell namespace is again created by the controller, and it is kind of like belong to the project. So today there is no real owner for that. So actually with this feature, like we are giving a real owner for that as well. So apart from that, if I tell like if you want to apply any network policies, any like let's say resource quotas and any governance policies into the project, that means like to set of components. So there is no way to handle it properly from the OpenChoreo today. So yeah. So what this idea came from is like when we were thinking about this, so we thought of like giving a same reusing the same pattern that is already existing in the platform today. So we have thing type and thing release binding, and rendered release, and finally rendered release is applied to the data plane. So currently this thing is components and resources. So what we are introducing is project. Yeah, this is like if you familiar with OpenChoreo, it's very easy to grab this content because it's very similar to the already existing life cycles. Yeah, so with this life cycle, we will be like introducing three new custom resources, and we will be doing some changes, introducing a new attributes into the existing project. So the project type, and so first one is the project type. Project type is the infrastructure template for a given project, and then the project release. So project release is the kind of the snapshot frozen capture of the project. Uh, it contains basically the project type spec plus whatever the parameters we specify in the project. Um, yeah, if you're familiar with our component lifecycle, so this is very similar to the component release. And we have the project release binding. So that is where we deploy project to an environment. So basically how we pin project release to an environment. Yeah. So if I go a little bit detail into these new custom resources that we introduce. So we have the project type. Similarly, like this project type is a namespace resource, but uh, according to the similar terminology for component types, we will be introducing we cluster project type as well. So yeah, this project type mainly has four main sections. Like it has parameters. These are the parameters that will be set at the project level, and it has environment configurations, and that will be like can be override at the project release binding when it is deployed into an environment. And it has validations, so we can have some cell rules some validation rules written in cell. So that is like very similar to the component type. And we have the resources array. So I will show example when I am going into the demo. So yeah, so one important thing to highlight here is like, as I mentioned earlier, so today we have the cell namespace, which is creating from the component when you are deploying the first component to an environment. As a kind of a side effect, there is no actual owner for that cell namespace. But with this life cycle, what we are doing is like we have mandated that cell namespace into the project type, so that you must include the project type when you are writing a project. So that is where like we give that proper owner for the cell namespace. Yeah. So the project release, it is the snapshot of project type plus the parameters that we specify when creating the project. So it has owner and the project type. This is the copied spec from the project type, and these parameters will contain all the parameters that we defined when we are creating a project. Yeah. So then when we consider the project release binding, so it has that is where we deploy given project release to an environment. So it has definitely it has the environment and the owner. So owner is the project that is referring, and it is specifying what is the release that uh, we need to deploy into this environment, and the defined environment configs that are in the project type. So that once this project release binding is created, the project will get deployed to that particular environment, and the all the rendered Kubernetes manifests from that project release binding will be applied to the particular data plane. So it will have some status conditions, and those will indicate that project is successfully deployed to that environment. Yeah. So if I go to a quick demo on how the project creation looks like with these changes. So let me open the OpenChoreo. So I'm having a OpenChoreo running in my local machine. So yeah, if I log into this, so as you can see, if you are familiar with this, like in the catalog, we can see all the resource types available in OpenChoreo. Like as I mentioned, I have already created a cluster project type that I'm going to use to create a project. So if I open that up, let's say I select this one. If I go to the definition, yeah, this is the project type, cluster project type that I am going to use. So in here, you can see the environment configs that the project release binding can specify when this is deploying, and the parameters that represents the parameters that we specify in the project when project is created using this project type. And again, it has an array of resources that those can be templated using the cell expressions similar to our component types and resource types. So you can see that cell namespace is there. So the OpenChoreo core level, there is a validation saying that you must provide the namespace here with the name having this expression. Yeah. So you can have the resources that you want to deploy when deploying the project type. Yeah, you can see some resources there like resource quotas and some limit ranges and network policies, things like that. And finally, it can have validation rules that is going to apply like when you are rendering this project type. Yeah. So then if I show you the creation of project, previously like it was just there was no actually wizard for creating the project, because project is just a representation, kind of a like grouping for the components. But now when we go and create a project, it is asking to select the template, that is the project type. So let's say I pick this one. Yeah, so then I have to give a name. And similarly, like I have to select what the deployment pipeline for this. And here, like it has a auto deploy. So what this means is, like when you are creating, when you create the project, so now it is not automatically deployed to all environments. But with this attribute, what you can do is, like when you set this, it would automatically create project release bindings with default configurations, so that the project is deployed to all environments once it created. So I will use this option, and let me create it. Like in the next step, like it is requesting the parameters that I specified in the project type. So for this, like I will fill up only the mandatory one and leave others as it is. And I will go to review and create. Yeah, so you can see that the project is created. Since I use that auto deploy option, you can see that it created 3 release bindings for deploying that project in all the environments that the project's deployment pipeline has. So yeah, if I go inside the project to the deploy section, you can see that project is deployed to all 3 environments. It's active. So it's like the this interface is very similar to our component deploy and resource deploy pages. Like you can also configure the environment overrides here. Yeah. So yeah, so that's about the demo. Yeah. So that's about this project releases. If you have any questions or anything, you can ask now. Yeah.
Thanks, Vajira. If anyone has any questions, you can go ahead and ask, or we can leave the questions maybe towards the latter part of the community call. So
Okay.
next up, we have Isela, who will take us through the scale to zero feature. Over to you, Isela.
Hi. So yeah, let me share my screen. Yeah, hope you guys can see the screen.
Yes.
Okay. So in the next version of OpenChoreo, which is supposed to come next week, we are introducing native scale to zero, basically auto scaling with SCADA functionality within OpenChoreo data planes. So from this module, one of the use cases is using SCADA to scale workloads from 0 to 1. So you can have, if you can think, if you have a like large cluster with a lot of idling services, for example, you can think of a dev or staging environment where you have the same production workloads, but they only get traffic very rarely. You can use this feature to scale them up on the demand. As well as with the same function, we are offering a KDA's massive variety of scaling types. For example, you can scale based on like time zone, like time windows. For example, if you have a production workload that expecting traffic on a particular window, you can have it set up to scale the replica count to like 5 or 6 during that period and automatically scale down when the period pass. Or you can even have like workers scale up on Kafka backlog and all, which is basically like anything KDA scaling support, you can now natively integrate with OpenChoreo. So to give you a small idea how this works, this SCADA scaling mechanism is built as a trait. So you have a component and you can apply this to any trait, any component that is built on this, that has this trait as a allowed trait in the component type. So once that's done, you just put some configuration, like how you want to scale your configuration parameters into this trait, and OpenChoreo would render that render all the artifacts need to do this scaling onto the data plane. So for example, this scale to zero HTTP mode, when you deploy the component, it will also deploy the interceptor route, scaled object, and CADA gateway backend if it's an external service, and as well as cluster IP, which basically allows gateway to talk to this scale down service. To show you this in action, I will give you another walk through how this works. So when a client, when the backend is scaled down, and if an external client try to connect to this scaled down backend, this would be the request flow that would go through. So it will first reach our edge gateway. So in this case, it's the K gateway, and with the K gateway, we have the K gateway backend CRD, which has configured. So the request would be routed to this interceptor proxy. So this is also a CADA component, where whatever the request that's come to this pod would be intercepted by this proxy. And then that proxy would go ahead and scale up the actual backend. And once the scaling up is done, it will redirect this request to this greeter CADA upstream service, cluster IP, which would hit the application. So this works actually within cluster traffic as well. So in this case, when you call the whatever the service address, it will get hit to this external service name, which would again redirect back to CADA interceptor, which would eventually scale up and then again redirect the traffic to the pod. So this is our README for this particular feature, and we have a lot of configuration options as well. So there's this configuration.md, which tell all the configuration parameters you can use with this. So, and when you're installing this, you need to do few things, like, for example, you need to add this cluster role patch, which is basically allowing our cluster agent to create the CADA specific resources we will need. And we also provide a few sample components which utilize this trait as well. So we have the HTTP cron worker. So that's basically like scale up within this time zone, like this period, and then scale down. And we have, so it will scale this batch workload, and there's the HTTP. This is a REST API, and we also have example for web apps. So to show you this in how this would look like in the console. So this is a component created from this component type which support scale to zero. And if I go to configure and deploy and component traits, I can see there are two traits attached to this. So in this case, I also attach the gateway, application gateway trait as well. So in this case, I'm using WS2 API platform to do JWT validation, as well as the CADA scaling, auto scaling trait. So in here, I have defined the replicas as 0. So that means this can scale down to 0, and as well as it can scale up to 5, right? So, and there are few ways to define how this scaling mechanism works. So that's actually part of the cluster trait itself, where you have to define where the like the scaling mechanism. So I think this uses Yeah, so this uses the request rate. So when the request rate is above a certain window, it will scale up for the next replica. And there are a few other cases like Keda described, which you refer to Keda's official documentation to understand like other scaling matrices. So, and if you go back to the deployment, so I have this deployment suspended, and if I check the artifacts, you can see the deployment was scaled down to 0. And if you check the replica count, it's also 0 at the moment. And you can see all the other artifacts that were registered with this particular change as well. So now I will send a request to this to showcase. So currently, if I do serial get out, I can see the deployment has 0 out of 0 replicas, and there is no pod running, and we can see the scaled object. So, and if I just hit the service address using this curl, which is basically like calling the endpoint, I would get this unauthorized error. So this is basically written from the gateway. So in this case, WSO2 platform gateway, which says this you need the token, right? So I will get the token from this command. So which will basically call Thunder and get the token. And I will see if the token was there. Yeah, so the token is here. And now if I call this same endpoint with the token, it will take a second to reply because it's behind the scenes, it's scaling up. So you can see we already got the reply. And if we check for running pods, you can see this is currently running, right? So you can see one deployment, and it will take like now if I run this, it's instance because now there's no scaling up happening. So it just goes directly to the pod. So yeah, and if you come here, you can see the application is now scaled up and suspended state is gone and it shows as active. So yeah, so with Keda, you have a lot of variety of other things you can do. So I just showed a like small use case, and this can help you with like a lot of other use cases as well. So yeah, that's it from me. If you have other questions, you can ask.
Thanks, Isela. Shall we move on to the next session? So any questions maybe we can ask towards the end of the call. Next, we have Janaka who will take us through the external observability modules. Over to you, Janaka.
Let me share the screen. Hope you can see the screen. I'm Janaka. I'm also maintainer of OpenChoreo. In this pick, I am going to explain and demo you on the external observability modules. When it comes to observability, users need to view logs, traces, and metrics. If you're familiar with OpenChoreo, we have provided those capabilities in our previous OpenChoreo releases as well. But with the limited support for different observability modules. For example, in our default observability stack, we have open search for logs and matrices. We use Prometheus, and for traces we use open search and the auto collector. So those are our default observability stack. In addition to that default observability stack, we have provided the Open Observe module as well for logs and tracings. Those are the modules that we supported in our early OpenChoreo releases. These are great, but when it comes to the real scenarios, not everyone wants to run their observability backends with this open source, OpenSearch, or OpenObserve. For example, if you are running your workloads in Azure, AWS, or GCP, kind of a managed cloud, you may not need to run self-hosted OpenSearch or OpenObserve due to reasons like cost, financial cost, and some expertise need to run those self-hosted OSSs. So user should have the choice to choose which backend, which observability backend you need to choose. The observability backend you choose should not be determined by the underlying IWP platform. So that's where our modular architecture actually peak. So with the observability modular architecture, we can support any observability backend. So now in the 1.2 release, we have supported observability modules for three of the major cloud providers, AWS, Azure, and GCP. As you show in this table, we have provided 9 modules for AWS, Azure, and GCP. For example, in GCP, we have provided modules for cloud logging, cloud monitoring, and cloud traces. Today, as a demo, I am going to show you the capabilities of observability with Azure modules. So let me go into the demo directly. Hope you can see my terminal. There, I have already set up a AKS cluster. I have listed the pods in that cluster. So in observability plane, I haven't installed OpenSearch or OpenObserve. So I am using Azure observability backend like Logs Analytics and Azure Monitor and App Insights as the observability backend. Here I have enabled Azure Management Agent, which is publishing logs to Logs Analytics. And I have also installed all 3 modules. As part of those modules, this logs adapter, metrics adapter, and tracing adapter are installed. Those are used for querying the observability data from that Azure backend. Further, that as part of the tracing adapter, we have installed the OTL collector, which is used to export traces to App Insight. That's the setup. Let me show you those capabilities through UI. I have already deployed a project and a set of components for demo. Let me go into the strip front-end component. Inside that components, if you go into logs tab, you can view the logs, historical logs and live logs as well. I have added the load here while before I start the demo. So currently it gives these logs. In the logs view, you can also filter logs based on environment or log level as well. Further, in the metrics tab, you can view the CPU usage and memory usage as graph as well. So this data that you show in this UI are fetched from the Azure backends like Logs Analytics and Azure Monitor. I can show you that from Azure Portal as well. This is the Logs Analytics workspace that I use in this setup. Here I can run this KQL query and show the exact same logs that are published into the Azure Logs Analytics workspace. So you can see that I have fetched the logs of the same component, and also you can view the metrics data from perp table as well. So those are the capabilities that we have added with those logs and metrics adapt modules. With those with those modules, we have also given the alert capability as well. So through the OpenChoreo, we can configure alerts as well. It can be log-based alert or metrics alerts. Once you create the alert, it will create the alert role in Azure side as well. This is the alert that I have already created in so that in the Azure portal, logs analytic workspace, alert role is created. This alert role is associated with the action group, which is pre-configured one. When we set up in the logs module, here we have set a webhook for that action group. That what that webhook does is it communicates with the webhook in the logs adapter. Then it is used for notification channel. For example, I said that I have added a load when I start the demo. With that load, it fired an alerts, and through the adapter webhook, it has reached my. I have set up email notification in the OpenChoreo. Through that, it reached my inbox that alert has fired. You can also view this alerts from Azure backend as well. Those are the capabilities that we added with logs and metrics module. In addition to that, we have added the tracing adapter as well for Azure as well. So that tracing is needed when you need to track your requests, where those requests go end to end. So if you go to the tracing tab, you can see that the traces and spans are shown there. You can view the span details if you need it. Those data are fetched from Azure App Insight and shown here. That's it for the demo. But you may be curious that how we support this any backend from OpenChoreo. Like we have supported OpenSearch, we have supported OpenObserve, and this cloud watch logs and logs analytics cloud logging. How we support any of these observability backend through OpenChoreo. We have done it through our modular architecture. To explain that, I have to go a bit deep into the observability architecture. You may already know that in OpenChoreo we have 4 planes like control plane, data plane, workflow plane, and observability plane. Observability plane is a optional plane where if you need observability, you can install that plane. Inside the observability plane, that modules are also optional. Like if you install the observability plane, that observer components is always there. Based on your requirement, you can install logs module law, tracing module law, metrics module, and it also based on your observability backend as well. Here in the diagram, it is installed the OpenSearch module. It installed the logs adapter and OpenSearch backend as well. Here, observer communicate with logs adapter to query the logs data from OpenSearch. If it is, let's say, you install the Azure module, then this is Azure backend, and logs adapter is there, but it has a different implementation. like it's specific to the Azure backend. So the thing that changes the implementation of the adapter, but all the adapters are following a well-defined uh, REST API contract. So due to that well-defined REST API contract, you can plug and use any of the observability backend. That's how our observability modular architecture works. Uh, if you are more interested in this observability modular architecture and how it works, I can share a blog by the Nilushan. At the end of this call, you can read that if you are more interested. That's all for the sneak peek demo. Thank you. If you have any question, you can ask.
Thank you. So we will be pushing the Cilium sneak peek a bit later towards the call because there's a small issue with the demo, so Isila is working on it. Next, we will move on to the code walkthrough. So over to you, Chaturanga.
Okay. Thank you, Kavishka. Okay, hope you can see my screen.
Yes, all good, Chaturanga.
All right. So, okay, I'm Chaturanga. I'm an OpenChoreo maintainer. So today I'm going to be walking you through the code of OpenChoreo MCP servers. So to get started, let's jump into OpenChoreo MCP setup and let's have a quick preview of it. So let me go into the documentation and see how we can configure the MCP servers with our AI assistants. So today I'm going to be using Cloud Code, and here we have easy configurations, easy commands that we can copy and paste to configure. So I'm going to go with browser-based authentication, and I'm going to choose Cloud Code and copy the commands and head over to the terminal, paste and hit enter. And like that, it has installed OpenChoreo MCP servers. One is the control plane MCP server. The other one is the observability plane MCP server. And if I open my Cloud Code, I should be able to see there are two MCP servers that need authentication. And let me go into MCP and select control plane one and then click authenticate. That'll open up a browser for me and let me log in with my credentials. I'm going to log in with my admin credentials. And yeah, and do the same for the observability plane one. All right, all good. So if I get the MCP menu again and go into the control plane one, you can see there are 130 tools, 130 tools registered. And if you go inside, you should be able to see what those are. And in the observability MCP server, there are only 11 tools. And we can talk about how we have managed to group the 130 MCP tools in the control plane MCP server to reduce the token load or the context load of the AI agents. All right, so the trick is we have organized them into 7 tool sets. I have listed them in here, and what you can do is if you don't need any of those things, you can configure the needed tool sets either before you start your OpenChoreo cluster at the installation step as a global toolset configuration, or else if you have installed everything and if you need the control over the tools you need per session, you can do it so by your authorization level and the tool sets you are going to request from the MCP server or any combination of that. So we can head over to Postman, and I have a already set up MCP server client in here, and I'm going to request the tool sets from tools from the tool sets component and project. So if I click connect, now I only see about 25 tools. But if I request everything, just like so, you can see I'm getting all the tools again, right? And then another implementation detail is since we had so many tools in the beginning, we did a kind of a restructuring, and we have collapsed some similar tools into namespace and cluster scope. For example, initially we used to have tools like get component types and get cluster component types, and those are merged into a single tool which accepts a single parameter called scope. Right. So let's jump into the code and see what's there. So before we see the code, let me explain the folder structure for the MCP servers. So we are going to be focusing more on the control plane MCP servers code because that is more complicated due to the toolset architecture. So in the package and MCP, we have the tools needed for our control plane MCP server and the server itself. And in the internal and OpenChoreo API MCP handlers, we have all the handlers which are handling MCP requests coming into the control plane MCP server. And the entry point for this one is, of course, inside the OpenChoreo API server. That is inside CMD and OpenChoreo API inside main.go. And also, there are a couple of configurations for this control plane MCP server, which is inside install helm control plane, and in this values.yaml file, this is a helm value file. We have OpenChoreo API, and under that we have config, and then we have a section called MCP. We have these configurations there. We can either turn it off altogether or otherwise select the tool sets needed for this particular OpenChoreo installation in this helm values file. Okay, so let's start browsing the code from the entry point, which is in the CMD OpenChoreo API /main.go file. So in the main function, we have this particular section. What we are doing is we are reading the configurations and figuring out what are the tool sets that have been enabled. And then we are creating this middleware chain, which consists of a logger and a 401 interceptor, which is required to teach the client how to obtain the token when it doesn't have a token in the beginning. And we also reuse the JWT auth interceptor to validate incoming token. This is shared, this is reused from API server. And we have our MCP handlers as well. And we are combining those middleware to our actual MCP server implementation and wiring them into the /MCP path of our OpenChoreo API server. All right. So let me go into actual MCP server implementation. Currently, we have two transport modes. One is STDIO and the other one is HTTP server. Streaming HTTP. And what we have done is we have wired the streaming HTTP server into the API server. And currently, the STDIO mode is not being used. Okay, so in streaming HTTP transport mode, what we are doing is we have a function to register the tool sets that are coming from the configurations, and then we are adding a receiving middleware, which is to filter out the tools. Just like I showed you in the Postman. For example, if you needed some tools from a couple of tool sets, these middlewares are handling that. And then we are creating our actual streamable HTTP handler and returning it. So let's go into the register file and into one of actual tool definition. For example, let's go into this register list namespaces too. And inside that, you can see the tool name and the permissions we have configured there, the permissions you need to access that particular tool. And there's this description which AI assistants need to identify and figure out what are the purpose of this tool. And then finally we have how this tool call is going to be handled. And how we have done is we have written an interface for each and every tool handlers. For example, this one, we have this list namespaces handler. And we can have many implementations of it. What we have done is we have implemented one in OpenChoreo API /MCP handlers, and the other one is in mock test, because we need to test these tools without actually invoking any of business logic. So let me go into an actual handler. So that's a simple wrapper of the underneath services, which is shared by both OpenChoreo API server and this particular MCP server. And once we call that service underneath, we get a result, and we just transform that result into a simpler form, eliminating Kubernetes related stuff so that AI agents can easily understand, and they don't get flooded with their context. Okay, so let me go back. And then if we talk about how we have done the tests of these tools and handlers, in the PKG MCP tools, we have set up test.go file. And in here, we have a couple of functions to test the servers with a couple of tool sets and with every tools. For example, if we check out the references of this setup test server, it is being used by this integration test, registration test, and validation test. Those tests are trying to check how is the MCP service is going to get integrated, and how are the MCP tools are getting registered, and how the inputs and outputs are getting validated. Those things are tested by using this mock server. Okay, so that's all about the control plane MCP server. And inside internal and observer, we have the observability MCP servers implementation. This is a fairly straightforward implementation. We have the server code. This is very similar to what we have seen in control plane as well. And we have the handlers, and we have a couple of helper functions as well. So that's all about OpenChoreo MCP servers implementation. Yeah, if you have any questions, we can take them.
Thanks, Chaturanga. I think we have one final demo. If Isala, you could take us through Cilium maybe a little bit quicker than usual, because I think we are almost out of time. Maybe a short demo and a short walkthrough would work.
Okay. Yeah, sorry. It didn't work the last time I was trying to show it, but I managed to got it working. So with the last release, we introduced Cilium as a networking module, and we have a bunch of upgrades in this release as coming as well. So if we use Cilium networking plugin with OpenChoreo, you get bunch of additional stuff on your observability and security side, right? So I will start with this. So I have this simple web app deployed on our cluster, which is running Cilium. And once you have installed the Cilium network plugin, you will see when you go to your Kubernetes artifacts, instead of the normal network policy, you will get the Cilium network policy. So if you get to the definition of this, you will see it has essentially the same, but you additionally have options to like do layer 7 based networking rules as well. For example, if you want to block off like admin port or admin path on your application, you can do it using these networking rules. And on top of that, when you're using Cilium, you get some additional observability metrics, notably the network throughput and latency. So when to do this, you don't need any instrumentation on the application side. This is happened because the traffic would be automatically sent through the Cilium envoy, which extracts these layer 7 metrics. So when you are debugging applications and you don't have like built-in observability, you can use Cilium to get insights to what's happening in the application. So on top of that, in the latest version of OpenChoreo, we have added this wire log feature, so which you can stream direct TCP packets from the server. So you can see I just send the request, and you can see the everything from the SYN act to all the way even into layer 7 stuff, right? So if we expand this up, you get like more data, like what is the source of this packet, what was the destination, and we get layer like Kubernetes context here as well, and you can get the raw JSON as well if you wanted. So this is what Cilium produce, and we have this UI. You can easily stream things from the cluster. And if you see like, so these are layer 3, and if you click on one of these layer 7 replies, this is actually a request. And so I will first go for a request. So in here, when it's layer 7, you get much more data, like you get the HTTP method, the URL, and you can go to this and get headers that was sent with this. So you can debug things much more easier. And if you go to a let's say a reply, so this is a reply, and go to headers, you get reply headers here, like basically response headers, as well as you can get the status response as well as the somewhere it should be the time as well, response time. So you can see here response time was 0 milliseconds. So these things come handy when you are debugging like network related issues on like large clusters. It's really annoying to get note down to a single component and figure out what's happening like on the wire. So this would help out a lot of people who are like debugging those sort, and you have like some bunch of like filtering options as well, and you can even download this. So everything here won't get persisted on the server, so it's just streaming directly to your browser, and once you stop, the stream would die and nothing would be recorded afterwards, but you can download the copy. So we have a bunch of more things coming up with Cilium as well in later releases. So as far as this goes, that's it. Yeah. So again, if you have any questions regarding Cilium or something, you can reach out.
Thanks, Isela. I think we are almost at the end of the call, but we can have a few minutes for questions. If anyone has any questions regarding the sneak peek features that we just showed, any technical questions or anything about the project updates, any questions are welcome. Seems like we don't have any questions. So if you do have any questions, you can always reach out to our team over the OpenChoreo Slack channel. We will definitely help you guys out if you have any questions. Also, we will open up the discussion issue for the next OpenChoreo community call. So then you can add any other discussion points you would like us to cover in the next call. So we are hoping to give you more sneak peeks with the latest releases that are the features that are coming with the latest releases. So if you do prefer a different format, or if you do want the call to be more of a technical discussion, do let us know. We are open to changing the format of the call if it fits you better. So we are open to any sort of suggestions. So you can give us some suggestions over our Slack channel or over our next community call issue as well. So thank you so much for joining the call. The video recording will be available soon. Have a great night.